Today we are going to solve mixture problems, and the way I like to solve mixture problems is set them up in a chart to start with, and then from there we can get an equation from the information in the chart. So we'll start with the amount of solution in the first solution that we have. And so if you look at it, it says a 4% salt solution is mixed with a 16%. So those are two different solutions. So we don't know the amount, but we do know the percent of salt of the two different solutions. And so that's what we're going to end up writing in there first. So I'm going to start with my 4% for the first solution, and then I also have a 16% for the second solution. And that's what it says right up in the first sentence. Now it asks how many milliliters of each solution are needed to obtain. So that's a key word there, to obtain. To obtain means to make, to get, the final amount. And so that tells me right there, that key word there, obtain, tells me that we are going to have a final amount here. And that final amount is going to end up being 600 milliliters. So that's what's going to go down here. And it's a 10% solution, so I can put the 10% right here. So what we do is we need to find out what amount for the first solution should go here in the second solution. Well, that's actually the question. See, it says how many milliliters of each solution are needed. So we don't know, so we have to assign a variable. And so what I like to do is I just assign the variable x to one of them. Since they don't ask for which one, it doesn't matter which one you put the x on. So I'll just put the x right here. Now, this is a total amount. So basically, these two amounts right here, they add up to make this total of 600. So since I don't know what this is, and I don't want to use a different variable, I'm going to write an expression that goes right here. And that expression is going to be the total 600 minus x. Because again, this is the total, so I've got to take away the smaller part from that total. Well, what we do with the chart from this point is we take these amounts, an amount of a solution, and we multiply it by the percent. Typically when we multiply by percents, we change them to decimals, but it'll be easier if we just leave them as percents. That way we don't have to deal with the decimals. So that's why in my chart I wrote down that when we multiply the amount of solution by the percent of salt, so we're multiplying these, it equals the amount of salt but times by 100. And so that way we don't have to deal with moving the decimals later on in the problem. So all I'm going to do is take these numbers here, the amount of solution, multiply it by the percent of salt. So it becomes 4x for this part. Here we have to use that distributive property, so 16 times 600. And so when we do that, that makes a 9600. Now we're dealing with bigger numbers because I'm not change these percents to decimals, but again, we don't have to deal with the decimals this way. Minus 16x. And then from there, we go ahead and multiply these two numbers as well. And 600 times 10 leaves me with 6,000. So I'm ready to solve, and the way we solve it is we just take these two amounts. Remember, the amount of salt in this solution times by 100, and the amount of salt in this solution times by 100 equals the amount of salt for the final solution times by 100. And so I can go ahead and add these two parts together. And when I do that, it's just a 4x plus 9600 and then minus 16x equals, and then I have 6,000. And so all I have to do is just do some opposite operations in this case. So I'll go ahead and subtract that 9600 from both sides and collect some like terms. And so remember, when you subtract that 9600, be careful. Make sure you redo it off to the side and make sure you put the bigger number on top when you do that subtraction. Otherwise, you might end up with an error. In this case, we probably wouldn't, but we'll go ahead and do that anyhow. And so we end up with a negative 3,600. Well, we still need to collect some terms as well. So these two terms are opposite in sign, so we can subtract them. And that leaves us with negative 12x. And then from there, all we have to do is divide. So we'll go ahead and divide by negative 12 here, and we'll have our answer. So the nice thing about this problem is The two negative signs should cancel. X equals, well, 12 goes into 36, and that's what's nice about this. Is go ahead and do that division there, and we're still left with two zeros we just bring down. So what that is X equals 300. So right there, this amount right here is what we just found, X, for the first solution. So you go back in your chart, it shows you what it means. It's the X is the first part, or first solution, that's 4%. So we had milliliters here, so I'll just put ml for milliliters, of the 4% salt solution. And we go ahead and do the work here to find out how much of the 16%. Well, all we're going to do, again, this is the 300, so we just need to do 600 minus 300. And when we do that, it just so happens to equal the same amount. So it's 300 again. And so there it is. We've got the 300 milliliters of the 16% salt solution as well. And that gives us both amounts. So they just happen to both be the same amount. Doesn't always happen that way, but it does in this case. Well, we've got another problem, and again, this first one is just like numbers 5 and 6 on tonight's homework, and this one, number 2, is just like number 2 that you're going to be doing on your homework. And so we start with the same chart. And again, I have the first solution, second solution. Those get added together. They mix them together, and they make a final solution. So let's see what's in here. It's a 280-liter solution is 20% salt. So this time, it's a little different. They're giving us the amount of the one solution, 280 milliliters. So I can write that one in there. 280 milliliters, and it's a 20% salt solution. So we already know that, which is different than the problem up above. And then it says how much pure water. This is a key word. I have this a little separated here to show you. Whenever they say pure, and they could have pure orange juice, pure water, pure whatever it is, whatever the topic is, that means that it's 100%. And so that's the key, and that's going to be the hint here. There's no salt involved in this, so it's all pure water. So it's 100% pure water. So how much salt would be in there? Well, no salt means 0% salt. So how much? We don't know, and so let's go ahead and assign the variable x. So the second solution is the water, and x is the amount, and that's what the question is. And how much salt? Well, it's 100% water, no salt, so 0% salt. The final solution, well, it's the same as this. Remember, you're adding the two solutions together. You're mixing them, and then you're going to get a bigger amount. So the final should always be bigger, so we have to add them. Well, what's different about this problem compared to the last is that, again, we know one of the parts. And so when we go ahead and come up with our final solution, that is an expression, 280 plus x. Well, what's the percent supposed to be? Well, looking over here, it's supposed to be 14%. So that's the number that goes here. Well, remember, all you're doing on these problems, these percentage problems, is multiplying the amount of solution by a percent. But I like to keep the percent as a whole number rather than a decimal, so we don't have to deal with the decimals later. So when you do that multiplication, you get an amount of salt, but it's times by 100. So let's go ahead and do the work there and see what we get. So 280 times by 20. So 2 times 28 leaves us with 56. And then you just count up the zeros. 1, 2 zeros, so 5,600. Well, 0 times x, we like that. That just makes 0. No number there. And then over here, we have 14 times by 28. And so off to the side, I got to do that work. 28 and then times by 14. So I know there's a 0 here, so I'll count that later. So let's just do the 14 times 28. Makes 32, and it makes an 8 plus 3, leaves me with 11. Carry a 0, and then I have 8 and 2. And so I add that stuff up, I get 2, 9, and 3, and then just bring down that 0. So 3920, and then plus 14x. Well, from that point, it's just like the last one. Remember, you're adding the amount of salt together, and then that'll equal the total. So let's go ahead and add that stuff up. And in this case, we don't have a whole lot to add up, which is 5,600 plus 0 makes 5,600. And so this all equals that 3920 plus 14x. Well, we can go ahead and subtract that 3920 from both sides. See what that ends up giving us here. And we do that subtraction, and we end up here having to borrow a little bit. And so we see that borrow all the way back from that 5, change that to a 4, 16 changes to 15, and do the subtraction. So we get 0, 8, and that gives us 6, and 4 minus 3 makes 1. So 1680 is our number, and 14x is the value that we have there. So we have a little bit of division to do. And we go ahead and do that division, and 14 into 16. Oh, that's nice. We can figure that part out. So let's go ahead and do that division off to the side here. 14 into 1680. And so that goes one time with 2 left over. And oh, 28. Nice. That goes in evenly 2 times. And so 120 is the number. So 120 is our value of x. And so let's go back in the chart and see what that is. Oh, yeah, that's right. X is the second solution. That's the part that's 0% salt. Oh, yeah, that's the pure water. So that's what we were supposed to find. And that's the answer there is 120 milliliters of that pure water. And there it is. So those are 2 different mixture problems. And that's pretty much as tough as the mixture problems get. We have these 2 different types, where one we're giving the final solution and one we're given a part. And we'll see a different type of mixture problem where we don't have percents tomorrow.